Hey, what's going on guys? My name is Madison Charlton from MLC Tech, and now today we're going to be diving into some details on Samsung's next generation of GDDR7 memory technology for the next generation of GPUs, which is set to offer 37 gigabits per second in its pin speeds, which is apparently 54% faster than GDDR6X. So sit back and relax as we dive into the latest expected GPU technology coming later this year. Now, it's been reported by TechRadar that Samsung is all set to present its next generation of memory technology, that being GDDR7, at the 2024 IEEE International Solid State Circuit Conference in San Francisco next month, with Samsung holding a session called a 16GB 32GB per second GDDR7 DRAM with PAM3 optimized, with TRX equalization and ZQ calibration, where in this very session they will be expected to unveil the next generation of graphic memory technology. Now, with it being reported that each pin on these GDDR7 memory chips will have a memory capacity of 37 gigabytes per second, it's quite a ridiculous uplift and marks over a 50% improvement in performance compared to the existing GDDR6X DRAM, which only maxes out at 24 gigabits per second on each pin. And Samsung is not stopping there with the latest iteration of GDDR7, they're also planning on introducing GDDR6W, with this memory reportedly having of double the capacity of pre-existing modules and 64-bit DRAM. And with all these improvements, we're finally getting towards what could be truly called the next generation standard of memory technology. And while GDDR6 is rated for up to 24 gigabits per second speeds on each pin, we've only seen a maximum output of 23.5 gigabytes per second so far from the RTX 4080 Super from Nvidia, so at the moment devices still currently aren't saturating the full bandwidth available to them on these GDDR6 modules, but it's very promising for the future of graphics technology. But in terms of previous reports, just a few months ago Samsung stated that they had internally reached speeds up to 36 gigabits per second with GDDR7 memory, though it's unlikely that we'll see fast speeds achieved out of these chips, as is expected will be nearing the stage of mass production of these new memory chips, so it's unlikely there'll be much more work done and further refinements done to these chips, as we are currently on the verge of these chips being announced and launched into the mainstream markets. And of course the demand will be high for these chips to fulfill the next gen gaming needs and also AI GPU lineups, where we can expect around 32 to 36 gigabits per second speeds in the next coming generation of GPUs. But what does the speed of 37 gigabits per second actually means? If I just say that as a raw figure saying these memory speeds will be capable of this bandwidth, then 37 gigabits a second doesn't sound all too impressive. But when I describe this rated speed, this is for the rated bandwidth that each individual pin layout on the back of these chips can pass through. So this isn't the total bandwidth that the module can do in total, this is just the amount of data that can pass through each individual pin connector on the back of these chips. So let's break down what theoretical speeds that this actually means for real world performance. And this can vary on the bus configuration of a GPU, so speeds will vary depending on that. But let's just break down the most common GPU bus widths that we see out there. On a 512-bit bus, this will mean for a theoretical throughput of 2,368 gigabytes per second, that being 2.3 terabytes a second of memory bandwidth. That is crazy. But a 512-bit bus isn't really seen as much these days on modern end gaming GPUs, though I do hope that it will return for the latest generation of GPUs. But on a 382-bit memory bandwidth, which is what we're most likely to see, that has a theoretical throughput of 1,776 gigabytes per second, still very impressive. Jumping down to 320, this could mean for 1,480 gigabytes a second. Jumping down to 256, 1,184 gigabytes, 192-bit, 888 gigabytes per second, and on a 128-bit bus, only 502 gigabytes per second, which are figures not to scoff at by any means. And quite frankly, I don't like the direction some GPU manufacturers have taken to dramatically reduce the memory bus of certain GPUs, as essentially you are capping performance that you can get out of these memory chips. Now, of course, lower end GPUs won't saturate all of this memory bandwidth, but as we move towards the direction of games saturating more VRAM and favouring faster in DRAM throughput compared to traditional just pure GPU core performance alone, I think it's very important that we see higher memory bandwidth put through next generation GPUs, as that's the direction the gaming world is going in, where they rely much more on memory bandwidth and speeds opposed to just core clocks alone. Which that is isn't me saying that none of that's important, of course it is, but it's just the way that modern gaming titles utilises not just this one thing, they prioritise and favour having uplifts in this and more, just to make a more overall package and better gaming experience and utilisation of its hardware. Now, memory bandwidth isn't the only improvements that GDDR7 is bringing towards the next generation of GPUs. The memory will also offer 20% higher efficiencies, and that is so fantastic to see, considering that memory consumes a high amount of power for high-end GPUs. For example, when I had a 3090, the VRAM modules on the back of that would reach 120 degrees, which is just absolutely crazy. So I think it's great to see that we take this step towards higher efficiency, as this could yield better performance, better longevity of components, and also lower operating temperature, which improves the thermal performance of a PC. And apparently this memory will also include technology specifically optimised for high-speed workloads, and there will also be a low operating voltage option designed for applications with mindful power usage such as laptops. So I think it's great to see that we're also getting better overall power management with these chips. It's not just, oh, we have this new super duper powerful chip that we can scale up to this type of power budget, and overall power efficiency is going to be greater than what came before. I think it's also great that they're also tailoring these chips to be used in different use cases which need to use much lower power budgets. Then they can scale up these memory modules to use much more power on higher end desktops. And we can also expect better thermal performance. Now, as stated earlier, having a more efficient chip will reduce thermal performance, but that's not the only improvement to thermals that Samsung are making. The new memory standard will utilise an epoxy moulding compound, otherwise known as EMC, with high thermal conductivity, which reduces thermal resistance up to 70%, which we've seen Samsung take a sort of approach on their mobile SoCs with the launch of their Exynos line of SoCs, where they've redesigned the packaging of those chips to improve thermal performance. So I'm glad to see Samsung continue this approach on its memory modules. And it was also reported that back in August, Samsung was sampling its GDDR7 memory DRAM to Nvidia for an early evaluation of its next-gen gaming graphics. But that's not a guarantee that it will show up on the 50 series of GPUs, though it's more than likely that we will see it appear on them. But I think it's also going to be very interesting to see how this new memory technology stacks up in the market, with there being a recent report in the surge of high bandwidth memory from SK Hynix, where their memory solution for GPUs were more tailored for high-end AI and higher enterprise work cards. So it's going to be interesting to see if Samsung can slot in as a competitor for SK Hynix for those high-end AI workloads, though I definitely expect this to be brought to the mainstream gaming line of GPUs. And with its increase in memory bandwidth, I think it's going to be great for the AI market of GPUs, though it's going to be met with some tough competition, but at the same time, competition is great. And when there is extreme competition in the super high-end market of high-end AI compute and high-end enterprise workloads, it means the technology will also trickle down to us consumers on these more mainstream level cards. I say mainstream level, a 4090 will cost almost $2,000, and that is still classed as a mainstream card, so it remains to be seen. But I'm super excited to see this new evolution in memory technology, and it's just going to be great for the wider industry as a whole. Whether you're an enthusiast gamer or someone who delves into more productivity-based workloads, I think this is going to be really good for the future of GPUs. Let me know all your thoughts and opinions around this topic in the comments down below. What do you think of the latest iteration of GDDR7 memory technology? Will you be eyeing up a GPU with this RAM later on this year, or will you be hoping to score a good deal on current gen or previous gen GPUs? Let me know all of that in the comments down below. Anyway, I have been Madison Charlton from MLC Tech. Thank you so much for watching today's video. If you like this video in any way, shape or form, make sure to give this video a like and maybe subscribe for more content like this in the future. Thank you so much for watching, and I hope to see you in another video soon. Goodbye for now.